Dear audience, I would like to present my 9 months progress of my PhD thesis about the biotechnological improvements in clinical hemato-oncology. My name is Ádám Szilágyi, and my supervisor is Miklós Garami. My SMS is Mark Hánátfői. And our vision is to provide new therapeutic solutions in hemato-oncology. But for that, I would like to show the big picture of our current knowledge about the novel therapeutic options, CAR T cells utility on a clinical level. For that, I would like to do 2 projects, which is kind of related to each other. Firstly, to compare the efficacy and toxicity of the CAR T cells against the conventional therapeutic types. And after that, we will check these CAR T cell products between each other, but not only about efficacy and toxicity, but additionally their cost effectiveness too. So back to the first project. This will be a systematic review and meta-analysis. And what's the importance of this topic? Firstly, it's very important to notice that 1/3 of the patients in hemato-oncology couldn't respond for the treatment. And we have still a very high chance to die in cancer, which is about 15% right now, according to the National Cancer Institute. So these patients definitely need novel solutions. For example, chimeric antigen receptors, or CAR T cells, can provide a very good therapeutic solution for them, according to recent pediatric and adult hemato-oncological tests. Our aim is to identify that who could benefit the most with the least side effects from the usage of CAR T cell therapy. So the question is that does the application of CAR T cells change the rate of toxicity and efficacy compared to the conventional cancer treatments? We examined, of course, hemato-oncological patients, and we compared the CAR T cells with the conventional therapies, for example, chemotherapy, and checked several important factors of toxicity and efficacy. For example, response and survival. More details about it later. Our hypothesis is that the CAR T cell will increase the efficacy and decrease the toxicity. For that, we made a systematic search in 3 databases and found about 42 articles for the data extraction. And we have ongoing analyses about the response and survival. For response, we will use odds ratios, and for survival, we will use the hazard ratios. We will examine multiple myeloma, non-Hodgkin lymphoma, and leukemia. For that, we will check their overall survival, the progression-free survival, the event-free survival, and the complete responses and the overall responses. This was my preliminary result from last time, and this is about the comparison of CAR T and standard care regarding the overall survivals. But with a deeper analysis, we have to mention that this is not enough. Why? So this is the problem of the biological treatments, we can say. Firstly, the patient will get an apheresis, and the blood sample is taken to the laboratory or the company who creates the product, the gene therapy. It takes a lot of time, more than a month. It's depends, it's an average number, but you can see there. And the CAR T cells are taken back to the patient after that time. And this is the exact time when the patient gets the infusion. Until that, they use conditional therapy. So, but we know that during that time, a lot of patients are in risk, so some patients will die. So the apheresis received population is always higher than the infused patient population. You could say that we should check only the infused patients. It's not that simple, because if we want to do randomized control trials, for example, comparing the CAR T cell with chemotherapy, we couldn't just take out the only infused patients, because we have to do the randomization before the apheresis, before deciding which kind of treatment will the patient get. So we have to examine them side by side. So we will have 2 × 2 measurements: observed enrolled, adjusted by any statistical method, and the observed infused and the adjusted infused. Enrolled means that they went to apheresis. Infused means that they went to the apheresis and the infusion also. So by this we will continue with with building up these press plots to have them with these measurement types. And I already could say that we will have a high quality methodology, and our implication is not only about the CAR T cells, it could be a message about, in general, about the biotechnological improvements regarding this problem that we can see here with the follow-up times. But we have a problem that we have only 3 RCTs right now, and we have very short follow-up times because this is a very novel therapeutic solution. So right now we are finished with the data extraction, and we are working on the results, and we will have about 18 plots, and we will also build up KM curves which are already in progress. Going back to the second project, where we additionally gonna see that these 6 already FDA approved products are working in the patients, and we will compare them with each other. Why we additionally study the cost effectiveness? Because this therapeutic solution is an extremely expensive one. And we have to see that, for example, in this case where we have for example, in these 2 cases, when we have for multiple myeloma 2 options, which one we should use, which is more cost effective. In the right side, you can see how this CAR T molecule looks like. So we have to find out that from these currently used CAR T cell products, which is the most beneficial for the patient all in all. So our question is that does the type of CAR T cell product affect the efficacy, toxicity, and the cost effectiveness? And our hypothesis is that it does affect it. And additionally to our responses and survivals, we will also check the toxicities. We will also check, for example, the incremental cost effectiveness ratio. So we will conduct. We conducted this systematic search in 3 different databases, and this is where the project is at right now. And altogether, summarizing my project, we will compare the CAR T cells against the conventional therapeutic solutions, and we will additionally discuss what are these products are, which products are better than the others. So thank you for your attention, and I would like to finish my presentation with a quote from Rick Schwab, who is a Dutch neuroscientist. We must accept the fact that it is possible we know something without knowing why we know it.
Congratulations on your work. I just would like to ask regarding the first project. You have mentioned on the slide that you found out about 23 articles via citation chasing. But I haven't seen them on the data extraction, like with the numbers. So if you can explain me if you decided to exclude them or what was the reason. Thank you very much.
Thank you very much for the question. It's a good question because since this is so the follow-up time, as I said, very short. This means that these studies are ongoing studies. So we have 1 year, 2 year, etc. Results. So when we found new articles, these are the updates of the articles of the that we checked before. So since that small time, even the small time, a lot of new articles, new updates are available. Thank you.
I was wondering, you talked a lot about the process of CAR-T therapy. Is there a possibility to shorten the time of the gene editing process before the infusion?
Thank you for your question. This is very important because it's possible. Mostly this long time of the process is because the shipment, so it's mostly logistical. Sometimes, for example, every CAR T cell has to be done, for example, in the USA, regarding wherever the patient is in the hospital all around the world. So, yeah, we can shorten it, and also we should try to combine the therapies, and if we can do a combinational therapy, so we can also start the during the first type of therapy we can do the apheresis before, and after that the infusion will be much earlier.